Okay, so till now we have discussed two concepts in surface areas and volumes. The first one is conversion of solids, that we have melted one solid and made it into another form. Okay, one solid figure, it was transformed into another solid figure. And after that we have also discussed the combination of solid. We have discussed such figures, we have calculated the volume and the surface area, the total surface area and all these things for the figures, for the solid figures which are combination of different solid figures. Okay. Now after this, the third and the last concept that is left in this chapter is the concept of frustum. The concept of frustum. Now first let us understand what is a frustum. What I mean to say if I say frustum. Let us assume that this is a right circular cone. Okay, this is a right circular cone. In this right circular cone, I can see that this circle, this part represents the base of the cone, okay, and this is the radius of the cone. Let us say R is the radius of the cone. Now, as I have said that this is a right circular cone, it means the line joining the apex of this cone to the center of the base, this line is perpendicular to the horizontal. This line which joins the apex to the base of this cone, to the center of the base of this cone, is perpendicular to the horizontal. Okay, as I have said previously that we can have a cone like this also. Okay, this is also a cone, but this is not a right circular cone. Okay, I am going to deal with only this kind of cone, that is right circular cone. Now I can see that this is a cone. So you might have seen practical examples in which you have shape like this, for example the ice cream cone, okay, for example the birthday cap, but you might have also seen an example of such figure. You might have seen such kind of figure also in your practical life. This figure I have seen for bucket. Okay, what is this figure? This figure is of bucket. This is a shape of the bucket. Okay, you might have seen buckets in this shape and there is a handle above this. So we are not considering the handle, I am just talking about the shape of the bucket. Now I can see that this bucket, this shape do not resemble any of the standard solid figure that I have, that is circular cylinder, circular cone, cube, cuboid, sphere, hemisphere. Okay, it is not resembling any of those standard figures. Then how should I determine the area or the volume of the bucket? If I want to know how much volume, how much water this bucket can contain, so how should I determine this? There must be some way. Okay, you might say that you should fill water inside this bucket and measure the volume. No, but it's not a technical work. Okay, this is not a technical work. If I want to design a bucket, in this shape of a particular volume, how should I design? How should I measure? How should I analyze this kind of figure? So what we observed is that we have a right circular cone. This is a right circular cone, and for this cone, if I do a simple activity, a very simple activity, that I cut this cone like this. I cut this cone in a manner that this cut is parallel to the base. Okay, if I take a scissor, I cut this cone like this. Okay, I cut this cone, let us say this is a paper cone, and I cut this cone like this in a way that this cut is parallel to the base of this cone, then the figure formed this one this figure is known as a frustum. Okay, what is this figure? This figure is known as a frustum. So what is a frustum? A frustum is basically a part of a cone. So what is a frustum? Frustum is a part of a cone. Now how the frustum is made? What I did is I cut this cone from anywhere in between. In this height, I can cut it from anywhere. I can cut from here, I can cut from here, I can cut from here, anywhere, wherever you like. I can cut this cone like this in a way that this cut is parallel to the base of this cone. Then I will be able to see a figure like this. Okay, this particular figure, if I draw it separately, you will be able to see that this becomes a frustum. Okay, this kind of figure, this figure is known as a frustum. Okay, what happened is I removed the top of this cone, so the figure left looks like this. Okay, this is a practical frustum. Now, so what I can write is a frustum is a part of the cone. Second thing, it is made by cutting a cone from between such that the cut is parallel to the base of the cone. Okay, this cut that I made on this cone, it should be parallel to the base, then only I will consider this as a frustum. Now if you say that if it is not parallel, if it is a tilted one, for example if I cut this cone in this manner, then what will happen? There will also be a frustum, but we will not consider that frustum. Why? Because if I cut this cone parallel to its base, then I can see that the two surfaces formed, this base and this surface formed, both the surfaces will be parallel to each other. This is our task. Okay, our main requirement should be to make these two surfaces parallel to each other. So what I can say is, if the cone is cut parallel to its base, then the new surface formed is parallel to the base. Okay, the new surface that is formed will be parallel to the base, and that's why I will consider only such kind of frustum. So in simple language, if we want to define the frustum, what is a frustum? It is a part of a cone which is formed by cutting the cone such that the plane on which I am cutting this cone is parallel to the base. Okay, or the cut is made parallel to the base like this. So the figure left will be known as frustum. Now let us have some terminologies related to frustum. If I make a frustum like this, Okay, so this is a frustum, and if I want to see that it is a part of a cone, then what I can do is I can extend these two lines and like this, and you can see it is forming a complete cone, but I am considering only this part. Okay, so what we have previously discussed about cone is that height of the cone means the distance from apex of the cone to the base of the cone. So this is known as height of cone. Okay, I represented it using HC, that is height of cone. So we have defined height of cone in this manner, that height of the cone represents the distance from apex of the cone or the peak of the cone to the base of the cone. Okay, then we have defined one more terminology, that is radius of the cone. Okay, which is, let us say, RC. So how we have defined the radius of the cone? Radius of the cone means simply the radius of its circular base. Okay, radius of cone means radius of its circular base. Now I have removed this portion of the cone and I am left with this frustum. So we will define the height and the radius and all other parameters related to frustum. Okay, so let us understand. The first terminology is height of frustum. Now what is meant by height of frustum? Height of frustum is simply the distance between the two parallel faces of frustum. Okay, let us represent it by HF. Okay, height of frustum means distance between two parallel faces. Okay, this is known as the height of frustum. The second terminology is radius of frustum. Now I can see that in the cone I have only one circular face, okay, like this, but in the frustum I have two faces. This is one face, this is second face. So what I will do is I will call this face as base 1. Okay, I will call this face as base 1 and I will call this face as base 2. So we have two bases in the frustum, that is base 1 and base 2. So radius of this base will be known as the radius of base 1 of frustum, RF. Okay, RF1. So RF1 means the radius of base 1 of this frustum. Similarly, this is the second base. So its radius, like this, its radius, you can see this is the radius. Okay, this radius I will call this as RF2. So RF2 is what? RF2 represents the radius of base 2 of the frustum. This is the radius of base 2 of the frustum. You can see this base is not visible in case of cone. Okay, it is visible only when I removed the top of the cone. Okay, I removed this much portion of the cone, then only this face is visible. This is the second base of the frustum. So these are the two terminologies. The third thing that we need to understand about this frustum is, we can see this length. If I talk about this length, what we call this length? This length is known as slant height L. This is the slant height of cone. So this is the slant height of cone. Then similarly we will define the slant height of frustum, LF. Okay, this length is known as the slant height of frustum. So how we define the slant height? In case of cone, the definition of slant height means the distance from apex of the cone to the corner of its base. So apex to corner, this distance is slant height in case of cone. So similarly, In case of frustum, I will define the slant height as the distance from one corner of the first base to the second corner of the second, to the first corner of the second base. Okay, that is the distance between the corners of the two bases, like this. This distance is known as the slant height of frustum. Okay. Now, so this is just terminologies related to frustum that we need to understand, and after this we will going to deduce how to calculate the volume of this frustum. We will going to calculate the total surface area, we will going to calculate the curved surface area, area of base, and all the things that we have calculated for standard solid figures. Okay. Okay, so first you note this is the basic concept of frustum. After this we will going to define, we will going to derive the formula for volume of frustum. Okay, let us now discuss the concept of volume of frustum. We will going to discuss, we will going to derive volume of frustum. Okay, the volume of frustum means how much water it can contain. Okay, the amount of water that this frustum, this solid figure can contain will be defined as its volume. So for that, let us draw a frustum. So to draw a frustum, first we need to draw a right circular cone. Let us say that this is a right circular cone. Okay, this is a right circular cone. Okay, let me draw its base again. So this is a right circular cone. In this right circular cone, this is the apex of the cone. Okay, let us say this apex is named as A. I named this apex, I named this top as A. After that, this is the center of the base. Let us say the center of base is O. O represents the center of the base. Okay, then from this center, if I draw a line like this which touches the end point of this base, then this line represents the radius of this frustum, radius of this cone. Okay, this is the radius of the cone, and let us say this corner point is B. Okay, so this point, this corner point is B, this is the center of the circular base, and this represents the radius. Let us say radius of this cone, I represent the radius by R1. Okay, what I did is I represented the radius of the cone by R1. So R1 represents radius of cone. This is a cone that I have defined, and R1 represents the radius of cone. After this, I will going to define the height of the cone. So how to define the height of the cone? We can define the height of the cone in this manner. So the distance from the apex to the base of the cone represents the height, and this, let us say height of this cone is h1. So h1 represents height of cone. Okay, what h1 represents? h1 represents the height of this cone. Okay, so we have defined the height, we have defined the radius. Now after this, what I will do is I will cut this cone. I will cut this cone from anywhere in between this A point and this O point, such that the plane by which I am cutting this cone is parallel to the base. Okay, I am not cutting it like this in tilted manner. Okay, in tilted manner, what I am doing is I am trying to cut this cone in this manner, not like this. or not like this, not in any tilted, not in any inclined manner. What I am going to do is, this cone will be cut like this, such that this plane of cut is parallel to the base of this cone. So let us draw a plane, let us cut this cone like this. Okay, so this line represents, this line, you can see this line represents the plane of cut. Okay, I cut this cone like this. So what will happen if I join this line? I can see this is the plane of cut. So what will happen if I cut this cone from here? This portion will be removed. Okay, this portion will be removed. So let us first join the apex of the cone to the center of the base, this. Okay, and I can see when I cut this cone, the portion that is open to atmosphere is this one. Okay, if you remove this top, then you can see this circular base available. Okay, this part will be removed, this upper portion will be removed, and so this represents the top. So what I can see is there is a frustum formed with this as first base and this as another base. What I did previously, I named this base as base 1, okay, and I named this base as base 2. So this is what we have done previously, and I have marked it in such way. Now after this, as I have cut this frustum, I have cut this cone from this part, okay, from this part. So what will be the height of the frustum? What will be known as the height of the frustum? I can see that this green line represents the line from which this cone is cut. So this becomes the base. So the distance between the two bases is defined as the height of the frustum. So definitely here I will mark the height of the frustum as the distance between the two faces as this one, and I will represent the height of frustum by h. Okay, so h will represent height of frustum. So this is another terminology that we have defined. Now remember, I told you that for frustum we have two bases, this is first base, this is second base. So definitely for two bases we have two radii. So this is one radii and another one will be this one. So this second radius, how to mark this second radius? I can see that this is a line which joins the apex to the base, and this line is perpendicular to the horizontal. That's why the point where this plane of cut and this line intersects will be the center of base 2. Okay, this particular point represents center of base 2. This is the center of base 2. Why? Because this is a right circular cone. This AO line is parallel to is perpendicular to the base, and this cone, this plane, the plane by which I cut this cone, this plane is also parallel to the base. So definitely this line is perpendicular to this plane of cut also, and this point is the center of this base. Why? Because this cone is a symmetrical figure. Okay, so now we have defined the base of, so the center of base 2, and I named this center as, let us say, C. Okay, C represents the center of base 2, O represents the center of base of cone as well as the center of base 1 of this frustum. Okay, further, as I named this corner as B, in similar manner let us name this part, this point, as, let us say, D. Okay, this is point D. So we have defined one radius of this base 1 as R1. Now let us assume that this radius, this CD represents the radius of base 2, this is the base 2. So let us name this radius as R2. Okay, so what I say is R2 is the radius of base 2. Okay, R2 represents the radius of base 2. So these are some terminologies that we need to define. Now further, try to visualize this figure. If I cut this cone from this line, then what will happen? This cone will be broken down into two parts. Okay, the one part will be the top portion, this one, and the second part will be this one. So this represents the upper part. Okay, and how this upper part looks like? This upper part looks like a right circular cone, because it is deducted, it is cut from this bigger right circular cone, and since it's a right circular cone and this plane of cut is parallel to the base, that's why this cone will also be a right circular cone. Okay, and the bottom of this cone will become like this. So this is the bottom of the cone. Okay, I can see that this particular cone is divided into two parts. This part will be known as the frustum, and this part will be known as the cone. This will again be a cone. So for this cone, let us define one terminology. What about the radius of this cone? The radius of this cone, I can see when I cut this cone from middle, the radius, the base of this cone and this frustum will be same. Okay, both the bases will be same because it is cut like this. So upper part will be known as a cone, the base lower part will be known as a frustum. So both these portions, this cone and this frustum, have the same base. That's why I will say the radius of base of this upper cone is also R2. Okay, so this R2, which I named as the radius of base 2 of the frustum, will also be the radius of this small cone. Okay, now further, for this cone, let us define the height of this cone. How to define the height? I can see this A represents the apex of bigger cone as well as the smaller cone. So from this apex and till this base, this represents the height of cone, and let us say this is h2. So what is h2? Let us define h2. h2 is height of small or smaller cone. Okay, so h2 represents the height of smaller cone. Now, why I have deduced this smaller cone? Why I have observed this smaller cone? There is a reason behind that. Try to understand. What is my task? My task is to calculate the volume of frustum. So I can very clearly see that frustum is made up of, it is a part of this bigger cone. When this frustum is made, when I removed this smaller cone. So when the smaller cone is removed from the bigger cone, then the portion left will be known as the frustum. So I can write very easily that volume of frustum will be equal to volume of larger cone minus volume of smaller cone. Okay. Now this is the most important conclusion. What I can see is this frustum is made up from the bigger cone. It is a part of the bigger cone, and how it is formed? It is formed by removing this smaller cone. So I removed this smaller cone. It means what I did is from the bigger cone, from the volume of the bigger cone, I removed the volume of this smaller cone, and the final volume left with me is the volume of frustum. Okay. So our task will be to determine the volume of larger cone, to determine the volume of smaller cone, and then subtract both the values to obtain the volume of frustum. Okay. This should be our task. That's why I have defined the height of the smaller cone as h2, the radius, base radius of the smaller cone, which is same as that of frustum, that is r2. Okay. Now let us solve this. Our task will be to define the volume of frustum in terms of, now this is most important, in which terms we need to define the volume of frustum. We will define volume of frustum in terms of H, R1 and R2. Okay, in terms of H, R1 and R2. What is H? H represents the height of the frustum. Okay, R1 represents the radius of base 1 and R2 represents the radius of base 2. We will not include the height of bigger cone and height of smaller cone in calculation of volume of frustum. Okay, so it means what? It means what I need to do is I simply need to find the value of H2 and the value of H1. Okay, this is H1. The volume of this value of H1 and H2 in terms of R1, R2 and H. Okay, so our task will be to define H1 and H2 in terms of H, R1 and R2. Okay, if somehow I define the H and H1 and H2 in terms of H, R1 and R2, I will be able to reduce the volume of frustum. Okay, so for that let us see a very simple observation. You can see this complete height from AO is H1. Okay, and the height of this smaller cone is H2, and what I did is from this bigger height I removed this smaller portion H2, so the height left will be known as H, that is the height of frustum. So what I can write is height of frustum H is basically H1 minus H2. So H is equals to H1 minus H2, or from this I can say that H2, that is the height of smaller cone, is H1 minus H. I can see this H2 height as H1 minus H. Now after this, try to observe in this figure, in this diagram, I have two right angled triangles. The first triangle is ACD and another triangle is AOB. So I will consider in triangle ACD and triangle AOB. In both these triangles, what I can see is this angle is 90 degree, this particular angle, this angle is 90 in ACD and this angle is 90 in AOB. Okay. After that I can see this angle A is common in both the triangles. So what I have is angle ACD is equals to angle AOB, which is each 90 degree. Okay, and the second thing I have angle A is equals to angle A, which is common angle. Now what does this mean? I have this angle as equal in both the triangles, this angle as equal, so I will say that triangle ACD and triangle AOB are similar. Okay, they are similar by AA corollary. Okay, they are similar by angle corollary that you have studied in triangles topic. Okay, In the chapter of triangles, we have discussed about the similar triangles, and in that chapter I have told you what is AA corollary. So by AA corollary, these two triangles are congruent, similar. So if the two triangles are similar, it simply means that the ratio of their corresponding sides must be equal. So I can see from this, I can write, this implies AC upon AO is equals to CD upon OB. I can write this, AC upon AO is equals to CD upon OB. This is AC upon AO is equals to CD upon OB. Now what is AC? In place of AC I can write H2 upon, in place of AC I can write H2, this is H2, and in place of AO I can write H1, so this is H1 is equals to, what is CD? CD is this line which is R2, that is the radius of base, and OB is R1. So in place of CD I can write R2, and in place of OB I can write R1. So this is what I can write. Now after this I have the value of H2 as H1 minus H. So in place of this H2 I can write H1 minus H. So here I will write H1 minus H upon H1 is equals to R2 upon R1. This is what I can write. Okay. Now from this, let us write it somewhere here. I will write here. So I have H1 minus H upon H1 is equals to R2 upon R1. So if I simplify this, I will have H1 upon H1 minus H upon H1 is equals to R2 upon R1. Okay, and from this I can cancel H1 and H1, and I will be left with 1 minus H upon H1 is equals to R2 upon R1. So if I simplify this, let us shift this H upon H1 to RHS and bring this R2 minus R2 upon R1 in LHS, and you will get 1 minus R2 upon R1 is equals to H upon H1. So from this you will get R1 minus R2 upon R1 is equals to H upon H1, and if you simplify this, if you just cross multiply this, you will get H1 is equals to H times R1 upon R1 minus R2. So what is H? H is the height of the cone, and I have deduced the height of the cone in terms of H, that is the height of the frustum, the radius of base 1 and radius of base 2 R2. This is what our task is. Okay, our task was to define H1 and H2 in terms of H, R1 and R2. So I have defined this. So this is the approach that I need to follow. If I know where I need to go, then I can very easily approach. For example, if I do not know where I want to go, if I take my vehicle out and I do not know where I want to go, then how should I drive my vehicle? Where should I drive my vehicle? So in the similar manner, in this concept also, in this derivation also, you should know what you need to do, what you need to determine. Okay, what should be your task? So this is our task, and we have defined H1 in terms of H, R1 and R2. Now this is only the value of H1. What next left is H2. So we need to define H2 in terms of R1, R2 and H. Okay. So how to define that? We have a condition that H2 is equals to H1 minus H. So in place of H1 I can write H R1 upon R1 minus R2 minus H. So when you simplify this, it will become H R1 minus H R1 plus H R2 upon R1 minus R2. So this simply means that the value of H2 is equals to H R2 divided by R1 minus R2. This is the value of H2. H2 represents the height of smaller cone. Okay, the height of smaller cone. Okay, so let us take a 1 minute quick break, and first you note this, then we will solve this further. We will solve it from here. I will remove this portion, I will rub this much part, and I will use these values to deduce the final volume of frustum. So let us have a 30-second break.